Dr. Barnes here. Let's continue our discussions on the properties of Fourier transforms. We are on part 3, and here we're going to see the 7th property, which is convolution property. Convolution property. Okay, so let's see the convolution property. So now here, if f of x of t gives a Fourier transform of x of omega, then we're going to have x2 of t, also giving a Fourier transform of x of omega. So here let me make it x1 of omega, x1 of t, x1 of omega, x2 of omega, x2 of t, and x2 of omega. So so in that case, let me make here to be and. I'll make here and then here will be what then. Then we're going to have in the case whereby we do the convolution. So x1 of t convoluting with x2 of what t. And then that will give us a Fourier transform. That will give us a Fourier transform of x1 of omega into x2 of what? Omega. What happens is that the convolution and then the multiplication always vice versa. So convolution and multiplication are always vice versa. So here you see that the convolution is leading to what? Multiplication. That's what I mean. So now in terms of convolution, then what we have is that x1 of t, x1 of t, if it is convoluting with x2 of what? T, then I'm going to actually have minus infinity from what? Minus infinity to infinity, x1 of what? Tau into what? x2, into x2 t minus what? Tau, the what? The tau. Mathematically, this is what I'm going to what? Have. Then in terms of Fourier transform, of x1 of what? T convoluting with what? x2 of what? T, then I'm going to actually have what I have here, integral of minus what? Infinity to what? Infinity. Integral of minus infinity to infinity. Then I'm going to actually have what I have here. Which is x1 of t, which is x1 of what? T, into x2 into convolution with x2 of what? T. Into x2 of what? T. Which is let me bring this one here. And then let me bring this one minus j what? T the what? T. This is in terms of what? Of convolution. This is in terms of convolution. Then I can put these two equations together, and then I'll be able to have here infinity, here minus infinity. And then I can have my convolution, which is this one over here. So here x1 of what? Tau into x2 of what? T minus tau. Into x2 of t minus tau. The tau. The tau. Alright. So the tau. So I can have this one. But you know that I'm actually this is the mathematical formula for the what? For the convolution. Okay, this is for the convolution. But I have to also do the Fourier transform for it. So in that case, I must do something like this. Okay, I must do something like this. Okay, and then do another integration here, minus what? Infinity to what? Infinity. And then here is going to be what? E minus what? J omega what? T d what? Dt. Okay, so basically that's what I'm going to have. Okay, so now you know that whenever I have x2 of what? Of t, it actually gives me what? X2 of t, it actually gives me in terms of Fourier transform. X2 of t gives me a Fourier transform of what? It gives me a Fourier transform of what? X2 of what? Omega. Okay, so if I have x2 of what? T minus what? Tau, then it's going to give me a Fourier what? Transform. It's going to give me a Fourier transform of what? If I have x2 t minus tau, okay, then it's going to give me a Fourier transform of x2 of what? Omega into e exponent what? Minus j omega what? Tau. Okay, all right. So now, if I should make use of this equation which I have here, then I'm actually going to have this is what I'm actually going to have. I'm actually going to have integral of what? Infinity minus what? Infinity. Okay, x1 of tau, x1 of tau into this one. Okay, e minus what? J omega what? Tau. Okay, x2 of what? Omega. Okay, x2 of omega. All right, so this is what I'm going to have, and then it's going to be what? Because of here, it's going to be what? The tau. So I can bring x2 of what? Omega outside because it's not of interest right now. Okay, and then here integral minus, then I'm going to have x1 of what? Tau into e minus j omega what? Tau d what? The tau. Okay, so now when I have this one, what this one is actually going to give me, that's going to give me what? X2 of what? X2 of what? Omega. And this one is actually going to give me what? Another what? Omega. But it's going to give me what? X1 of what? Omega. Okay, that's going to give me X1 of omega. So if I should write that one, then I'm going to have what? X1 of what? Omega here. So in that case, what I'm going to actually have in this case is that I'm going to have x1 of what? Tau convoluting with what? x1 of t convoluting with what? x2 of what? T will give me a Fourier transform of what? x1 of what? Omega into x2 of what? Omega. Alright, so this is the proof for the what? For the convoluting what? Convolution property. Okay, when two signals are convoluting. Now let's go to the next property. Okay, so the next property shall be the multiplication what? Property, and that is property number 8. So multiplication property. Okay, so let's see about the multiplication property. So now here, if x of what? If x of t, okay, so let's say x1 of t will give us a Fourier transform of x1 of what? Omega. And okay, no, let me write here. And okay, x2 of what? T will give us a Fourier what? Transform of x2 of what? Omega. Okay, then we're going to have x1 of what? T into x2 of what? T. Okay, giving us a Fourier what? Transform. Which Fourier transform? Fourier transform of what? 1 on what? 2 pi into x1 of omega. X1 of what? Omega. Convoluting with what? X2 of what? Omega. Okay, so this is what we are going to have at this particular stage. Okay, this is what we're going to have. Okay, so how can we prove this one? So let's say the Fourier transform. Okay, well, so the Fourier transform of x1 of t into what? x2 of what? T. Okay, it's actually going to be what? It's actually going to be integral infinity minus infinity. Okay, x1 of t into what? x2 of t. x1 of what? T into x2 of what? T into e minus what? J omega what? T d what? dt. Okay, so that is what we're going to have. Okay, so now from here, what I'm going to do is that instead of x1, I will substitute what? The inverse Fourier transforms. Okay, so I will use what? Inverse Fourier transform. Okay, if I use the inverse Fourier transform here, then what I'm going to have is that it is going to be like this: integral infinity minus infinity. Okay, and then I'm going to get 1 on what? 2 pi integral infinity, okay, minus infinity into what? Infinity. Okay, and I'm going to get x1, let's say lambda. Okay, let's say lambda. Okay, to differentiate it. All right. Okay, so x1 lambda into what? E minus what? Lambda lambda here has to be what? J. Okay, t. Okay, all right. So now this one into x2 x2 of what? Of t into what? E minus j omega what? T the what? The t. So the only thing I have done here is that I have removed the x1 of t, and instead of see the removing the x1 of t, I have put the Fourier, the inverse Fourier transform of x1 of t inside here. This is the inverse Fourier transform for s1 of t. Okay, so now here, this is what I'm saying. From here up to here is the what? Inverse Fourier transform of what? x1 of what? T, which is the same as what? x1 of t. Okay, so instead of writing x1 of t, I can write the inverse Fourier transform for it, and it's the same. Okay, so now here I'll be able to get 1 on 2 pi can come outside here. I can here have here infinity minus infinity. Okay, I can have here x1 of what? Lambda into what? The lambda. Okay, into the lambda. Okay, into here infinity minus infinity. I can have x2 of what? T into e minus j what? T d what? dt. Okay, so basically here it gives me the what? The Fourier transform. Okay, it gives me what? The Fourier transform. Okay, but what happens is that this one I've not actually dealt with this one. Okay, so if I have this one here, let me bring this one also here. So here I'm going to have something of this sort. Okay, I'm going to have minus j lambda, sorry, minus j what? Lambda what? T. Okay, I'm going to have minus j lambda t. Okay, okay, so that is what I'm actually what? Going to have over there. Okay, so now here, because of here, I can write what? The t. Okay, so now if I have it this way, then what I can say is that it's equals to 1 over what? 2 pi integral of what? Infinity into what? Minus what? Infinity. Okay, x1 of what? S1 of lambda is equals to what I have here. Okay, I can say that x2 of what? T into what? E minus j. Okay, I can say e minus j omega minus what I have here, lambda into what? T. Okay, the what? The t. Okay, into the t. All right, so basically if I have this one, then what I can say that is that you see that basically this one is the what I have here is the Fourier transform. So what I have here is a Fourier transform, but this Fourier transform is going to be here. I'm going to have what? Minus infinity minus infinity, s1 of what? Lambda. And here this Fourier transform is what I have here, but here you can see that the Fourier transform is what? X of what? omega minus what? Lambda. Okay, x of omega minus lambda. Here it will be in terms of what? The lambda. Okay, in terms of the lambda. Okay, so now let us actually go back to the normal Fourier transform, the normal convolution that we normally would have. If I should liken this one to normal convolution, then it's going to be what? Here infinity minus what? Infinity. Okay, x1 of what? Tau. Okay, into what? X2 what? T minus what? Tau. Okay, d what? D tau. Okay, that is what I'm going to have here. Okay, so basically, if I should actually, if I have this one, then what it actually denotes, if I should do, if I should do a comparison, okay, if I should do a comparison with something like this, if I should compare, let's say, compare with what I have below here, okay, if I should compare with what I have below here, let's say I have integral minus what? Integral. If I should compare with normal convolution, okay, x1 of what? Tau. Okay, x1 of tau into what? x2 t minus what? Tau. Okay, d what? Tau. If I should compare these two, okay, then I'll be able to actually say that if I bring my 1 over what? 2 pi, then what I'm going to have is that I'm going to have here x1 of what? Omega. I can say that I have what? x1 of what? Omega. And this place becomes what? x2 of what? x2 of what? Omega. Okay. So basically, then I'll be able to say that Fourier transform of x1 of what? T into x2 of what? T. Okay. Actually should here, because I brought the Fourier transform here, I must make here equals to. It's actually equals to 1 over what? 2 pi x1 of what? Omega into x2 of what? Omega. Okay. Or I can say that x1 of what? T into x2 of what? T has a Fourier what? Transform of 1 over what? Pi into x1 of what? Omega into what? x2 of what? Omega. Alright, basically that is what I can say. So this is the multiplication property. See you in the next class. Thank you.